CIT212, and in today's tutorial happens to be the course CIT212, and we're going to be talking about defining problem system analysis. Let's hop straight into it. Now, when we say defining a problem, all right, CIT212, okay, when we talk about defining a problem, we are simply referring to, okay, that process, the process that involves, it takes considerable skills to determine the true cause of a system problem. Now, when we talk about defining problem, remember we said something about system analysts and how they go about gathering the necessary information, intels, all right, source, and even finding out if the cost of the request is worth it. Okay, but let's put that aside now. Let's assume the cost is worth it. Let's talk about defining the problem. It's highly essential if you want to provide solution to any problem. The problem must be well defined. So let's look into what it takes to define one. Okay, now it takes considerable skills to determine the true cause of a system problem. Considerable skills to determine, okay, it takes considerable skill to determine the true cause of a system problem. There are a lot of things involved. All right, there are a lot of things involved when it comes to determining or defining or figuring out the true cause of a system problem. Now, a system analyst might begin to define the problem by determining, okay, if the problem, just a moment, okay, by determining if, are we together? All right, by determining what? If the problem, trying to adjust my material very quickly, just a moment. Okay, yeah, I think we are good to go now. Now it says here that a system analyst might begin to define the problem by doing what? By determining if the problem can be classified according to one or more common types of system problem. All right, so classification is highly essential. All right, classification. Now, with a knowledge of common type of problem, the analyst can now diagnose a problem. All right, classification to become more knowledgeable. So having gotten enough knowledge about what the problem could be, then becomes what we refer to as diagonizing. All right. You can now diagonalize, all right, a problem by examining, all right, let's just put it this way, by examining, okay, its characteristics, its characteristics, all right, its characteristics. Now, let's look at some illustrations here. Now, now let's look at some classifications, some illustrations I mean. Now, a problem of, okay, reliability. All right, don't forget we're talking about defining a problem. And the problem could be a problem of reliability. All right. A problem of reliability speaks about a system suffers from the problem of reliability when procedures work some but not all of the time. When procedures work sometimes. Works sometimes. Then you can say the system is not reliable. Are we good? When the procedure works sometime, then we can say the system is not reliable. Okay? Now, when the system is not consistent, then we can say that the problem is the problem of reliability. Okay? Or when use of the same procedure leads to different results. All right? When the use of the same product, all right, but different results, then you can say it is not reliable. I mean, why can it one product leads to different results? It's an issue of reliability. Now, analysts must work continually to improve the reliability of systems. All right, definitely, system sometime a system that was once reliable might become unreliable. All right, so it is the responsibility of the system analyst to work continually, consistently to ensure that the system, all right, holds its quality. Now, they strive to do this by running software, all right, software tests to document that two runs of a computer program can lead to identical results by selecting equipment, and we have that. So what we need to understand about reliability is when a system doesn't give expected result or when it gives it on and off. So we also have the problem of validity. Here, we are simply referring to all right, systems that produce invalid results are often most troublesome to users and system managers. This system might be highly, all right, reliable. They may work all the time, but they draw incorrect conclusion. All right. When we arrive at an effective system but draws incorrect conclusion, all right, so the system can't validate certain programs. We also have the problem of accuracy. The problem of accuracy is similar to the problem of reliability. All right, accuracy is missing, then it becomes unreliable. All right, now a system is inaccurate when processing is error prone. Inaccurate when what? Processing is error prone, right? It's not as if it doesn't work at all, but it does. But it's just that sometimes, all right, there are errors every now and then. We also have the problem of, okay, timeliness. In as much as it's effective, it's reliable, it's validated, all right. But if unfortunately the time at which that information is needed, if it cannot be retrieved, problem of timeliness, all right. So it's not good enough to have information, all right. Getting them when needed is also very important. Okay. So we have that as that. Now let's take a step further. We have evaluating the problem. All right. Now we've talked at length about defining the problem. So let's talk about evaluating the problem. Now that you have at length gained enough knowledge about defining the problem and other intricacies involved, and let's talk about evaluation. The course is quite a voluminous one. All right. About almost 200 and something pages. That should be about 400 pages on hard copy. It's about 12 and something pages on soft copy. So we have a long way to go, and we need to increase the pace of our classes. So I'm going to see how we can fast track everything, and we can follow up this course by next week. And from there, we can actually take some other courses. Okay. So now let's take a step further. Now we have waiting the problem. Suppose that a problem has been identified. Okay. The next step is to what? The next step is problem evaluation. Problem evaluation there consists, okay, problem evaluation consists of asking certain questions. Consists of asking certain questions. Oh, awesome, awesome, awesome. Thank you very much for that. I do appreciate that a lot. Thank you very much for that. Now, let's take a step further. Now, it says here that let's assume that you already, all right, identified, okay, a problem. Then the next thing you are expected to do is to evaluate after identification. So we have sources of problem. One of the first questions we want to ask. after you've identified, while evaluating, you want to find out the source. Where did this problem emanate from? Where is the origin? All right. Where is the genesis of this problem? So we want to talk about the source of the. Don't forget, what you are doing is you are evaluating. Organizations usually face problems or have opportunity due to the following: new products. Now, source of it could be a problem, it could be opportunity, but we are being particular about problem now. All right. So we have sources of problem, a new product, all right, or planting of a new branch, new market or new process, failure of existing system, inefficiency and exist of an. These are questions, these are answers you'll probably get, all right, from source of the problem. Is it as a result of we just launched a new branch? Could it be as a result of we just launched a new product? Could it be as a result of failure of an existing branch? And so on and so forth. Now, we also have problem identification and definition. We talked about that. Now, we move straight ahead to what we refer to as feasibility studies. I wouldn't want us to rush into these feasibility studies at all, but I want to take, all right, I want us to take some points on it. Feasibility studies. Now, for those of us who has, all right, done something or come across courses like CIT212, okay, not in this level, yeah, not in this level. Courses like entrepreneurship and business, any course that has to do with business. Yes, this word you should have come across this word talking about feasibility. So when we say feasibility, what are we referring to? Okay, once a preliminary area of application has been identified, the superficial, the very beginning, it may then be subjected to more rigorous examination in what we refer to as a feasibility study. So, feasibility study is that study that is embodied, encumbered, made up of, consists of rigorous examination. All right, process of subjecting. All right, process of subjecting. All right, the identified problem slash opportunity towards a rigorous, let's not just use a rigorous, a more. So there was a rigorous before, but here is more like an in-depth, a more rigorous examination examination. And why do you have all this? Find out soon. Okay, feasibility is the determination of whether, all right, or not a project is worth doing. All right, keep wondering the law involved before a project is being taken upon. A lot of back and forth behind the scene, and for you to see that project, all right, successfully picked, then there's a lot of decisions and feasibility studies that have been done behind the scene. Okay, so let's take a step. Let's take a step further. Now we have. Let's call it a wrap for today. So we are going to talk about feasibility study from our next slide. But I don't want us to rush into it at all. I want us to take our time to go through it properly. All right. So thank you very much, everyone. Do have a wonderful evening. I look forward to see you all this else. Bye for now. Okay. Good night. Start. See you. Bye for now.